Guys, good morning. Today we are here to solve a question from the chapter integral functions, and let us see what does our question say. So we have to find the integration of e raised to the power x multiplied by 1 plus x, and in the denominator we have cos of e raised to the power x multiplied by x and its square, and we have to find the integration of this function with respect to x or dx, whatever you say. So how do we approach this question? The first thing that I need you to observe is that some part of the denominator is direct integration of the numerator, or we can say the numerator is the exact differential of some part of the denominator. Can you observe that part? Let me show you. You can see this thing in the numerator, and this part, let us call it A, and this is B. So if you observe carefully, then you can see that dB over dx is exactly equal to A. That is e raised to the power x x. And if we differentiate it on the both sides with respect to say x, then what we get? We get e raised to the power x into 1 plus x. Dx is equal to dt. So this is the thing that I am telling you. So now let us dive into the solution directly without wasting any time. Okay. So they have done the same thing. They have taken e raised to the power x multiplied by xst, and on integration they get what? They get the same thing. That is e raised to the power x multiplied by x plus 1 dot e raised to the power x dx is equal to dt. Now let us move to the next slide. Okay. So finally we have this. Now you can see that we can replace e raised to the power x1 plus x dx by dt, and e raised to the power xx by t. So what do we get? We finally get integration of dt divided by cos square t. Now 1 upon cos square t can be written as sec square t, and now we know that the integration of sec square x is 10x. So the integration of sec square t with respect to t is 10t plus c. But before signing off with the final answer, we need to remember that this answer is in the variable t. But the variable that we were given with in the question is x. So we have to back substitute the value of t into x. Or we can say the value of x into t. Actually we are replacing t by x. So our t was e raised to the power x into x. So we get our final integration as 10 of e raised to the power x into x plus c, where c is an arbitrary constant. So that is it. I hope you all got it. Thank you and have a nice day.